Chemistry, Unit 3, Electroplating. So, sometimes electrodes can also participate in the reaction when we electrolyze a solution, and that is in addition to water. Okay, so let's look at one example. When we put nickel sulfate solution into a beaker and electrolyze it using a certain voltage, and we use copper electrodes. Under standard condition, what could be the product at cathode and anode? At cathode, we know that is when reduction happens. So any species in this whole system that can gain electrons will be attracted to the cathode and competing for electrons. So nickel cation is definitely one. And then water is also one. And which one is the stronger oxidant, so the biggest bully in the schoolyard? That is, we have nickel and then we have water on the electrochemical series, and we know that the stronger oxidant is the top left, which means that nickel will be reduced at cathode at the end. Okay, and at anode, okay, so anode is where oxidation happens. So that means lose electrons. So as long as you have electrons to lose, you will be at anode and basically waiting to see who is the strongest reductant, right? So we have water, definitely can lose electrons. And how about sulfate, people ask? Well, as long as you are in VC chemistry, you do not need to think about any polyatomic ions in electrolysis, okay? They won't participate in competition in VC chemistry. Now, have we considered all candidates so far? Water and sulfate. Well, in this case, you notice that we used copper electrodes. Can copper lose electrons too? Of course, it's a metal, okay? So unlike carbon or platinum, who are really, really inert, even though they can lose electrons, but because they're so inert that they probably won't win any of the competitions. But copper is quite in the middle in the series, okay? So copper can also lose electrons here, which is also a candidate for anode species. Now let's look at their voltage on electrochemical series. Which one is stronger reductant? We have water and we have copper. We know that the stronger reductant is the bottom right. Okay, so in this case, copper is a stronger reductant than water. It is also in the system, so yes, it can participate in the reaction and go through oxidation. So what will be the overall reaction then? Well, we have nickel at cathode being reduced and copper out of the competition, okay, losing electrons and then deliver electrons back to the power supply. Okay, so the overall reaction will become this metal displacement reaction. Well, as the reaction goes on, you can imagine that ultimately, because copper is turning into copper cation, the mass of the copper electrode at anode will actually decrease. Anode, in this case, the electrode itself will be consumed. And as the reaction goes, we are producing a lot of copper cation, so the solution will eventually become copper sulfate solution. So where does nickel go if copper is marrying sulfate instead of nickel? So nickel, unfortunately, being attracted by external electrons, will then deposit onto the cathode as nickel metal. And this kind of deposit, they're normally quite even, and they don't come off easily. So it's as if out of this electrolysis, nickel metal is being painted onto the electrode. And this is what we call the cathode is being electroplated. It's basically saying it's covered with nickel, but like it seems to be a really strong coverage. It doesn't come off easily and it's very even. And the coating is the nickel metal.